We're now ready to talk about our PID controller design as well as some design steps. So what we can notice from this basic block diagram is our error signal right here is being fed through 3 blocks. So we're going through this bottom block K1, this middle block K2 over S, and this top block K3 times S. And so all of those signals are being added at a summing junction on the other side. And so of course this K1 block is going to be our proportional part. So this is our proportional, or our P. Our middle block, remember dividing by S corresponds to integrating in time, so this is going to be our integral, or I. And then our top block, we're multiplying K3 by S, so that corresponds to taking the derivative in time. So this is our derivative, or D. So there we have all of the components for our PID controller. So we can consider the overall transfer function for this this compensator network right here. So we notice that all 3 of those blocks are in parallel. So we can say that our compensator network has G of S, which is equal to K1 plus K2 over S plus K3 times S. And so if we want to combine those, of course, we can just find a common denominator. And so we can use common denominator of S. So we then have that this is K1 times S plus K2 plus K3 times S squared, all divided by S. And now I can clean up that numerator a little bit. So let me factor out a K3, and that's going to leave us with S squared plus K1 divided by K3 times S plus K2 divided by K3. And all of that is still over S. So looking at this equation here, for our compensator network, we can notice a few things. So first of all, we note that it is introducing 2 zeros and 1 pole. So 2 zeros and 1 pole, as we would expect, because our PI design, as you recall from our previous notes, is going to need a pole at the origin and a 0 very close to that pole. So pole at origin and a 0 close by. Whereas our PD design, we just needed to add a 0 at some specified location. So this needed a second, this is where that second 0 in this PID comes from. And so as we're going to talk about in our design steps here in a second, we're going to see that we can determine the values of these gains, K1 through K3, based on our sort of 2 separate parts here from our PI design and our PD design. So let's now talk about those design steps. And so we're going to get a chance to go through a detailed example, and we're going to put each of these design steps into practice and hopefully get a little more comfortable with them. So these are also listed on page 384 in the 8th edition textbook, so you can look there as well as a reference. So we're going to have 8 steps in total. So our first step is just going to be to evaluate the performance of our original system. So evaluate performance of our original uncompensated system. And so of course we need this because this is going to help us get our desired pole location, particularly if we're talking about making some % reduction in steady state error or some transient response characteristics. We absolutely need to know what that original system's response was. So very important first step that could often be overlooked. Our second step is, as we mentioned in the previous video, we're going to start by designing for our transient response. And so what that means is we're going to start by designing our PD controller. So we're designing our PD controller for our desired transient response. And so as we see from up here, this is going to give us our 0 location as well as a loop gain. So this is going to give us our 0 location and a loop gain. And so we're going to come back and we're going to see all of this in an example later on. So if any of this is a little fuzzy, hopefully it'll be cleared up later. So our third step is to simulate the system and just check that our requirements are met. So simulate and check requirements are being met. Our fourth step is if we didn't meet any of those requirements, we can just go back and we can redesign, or we can tweak our design a little bit from step 2. So redesign in 2 if required from our simulation in step 3. So these steps are a little bit sort of excessive in terms of their detail, but again, we'll kind of talk through each of these. So our 5th step is then to move on to our PI controller. So now we're trying to improve our steady state error. So we want to design our PI controller for our desired steady state error. And so as we talked about in the previous video, we could essentially switch steps 2 and 5 and do our PI controller first and then our PD controller. It doesn't make a huge difference. However, our book is starting with the PD controller, so that's what I've done to be consistent in the notes here. Okay, so once we've designed the PI controller as well as our previous design of the PD controller in step 2, we're now ready to determine specific values of our gains K1, K2, and K3. So now we can determine our gains K1, K2, and K3. And so ultimately what we're going to do to find those gains is we're going to compare our equation for our PI compensator and our PD compensator, sort of combined together in parallel, to this form of our general equation here. And so we'll be able to sort of inspect the two equations and how they compare to figure out those gain values. And typically what that's going to involve is figuring out this K3 value first. Once we know K3, we can then figure out K1 and K2. Okay, so we have 2 more steps then, and so these are sort of redundant, or not necessarily redundant, but a little excessive in the detail maybe. So again, what we can do is we can simulate, not stimulate, we can simulate our system, and we're going to check that requirements are met. So of course we can do that in MATLAB or Octave or some similar program. And so remember, this is important because as we're doing this second design phase for our PI controller, remember that we're going to be slightly altering what we had designed in this PD controller design phase. And so of course our 8th step then is going to be similar to step 4, and that's just going to be to go back and redesign if our simulation says we didn't do well enough. So redesign if our simulation shows that the requirements are not met. So hopefully that gives you at least a good rough idea, but as I said, we're going to be going through a detailed example, so we'll get some good practice with talking through each of these steps for a PID controller.